A very good morning, students. I hope all of you are doing fine at home. I hope all of you are studying. All right. So, welcome to a new lecture, right? So, today we are going to talk about interference of waves, right? Today we are going to talk about interference of waves. All right. First of all, we all know what waves are, right? Basically, this is a topic inside your wave optics, so that's why we are talking about waves here, right? Secondly, we are going to talk about interference of waves, right? That means whenever there are two different waves, right? Whenever there are two different waves, and when they come together, and then forms a different wave, right? So you can simply say, let's say you have a wave, let's say this is the wave, and then you add another wave with different, let's say phase, right? So when you add these two waves, how is the resultant wave is going to behave? Will it behave like this, or will it behave like that, or will it behave something different, right? Something different, right? So whatever it is, right? So this is something which we are going to talk about today. Interference of waves means when different waves, right? When different waves come together and when they meet, and after meeting, what is the next property that they are going to show? What is the next, wave that they're going to, that the wave that we are going to see, right? Okay, so if that is clear, let's move to the topic, right? So let's imagine, there is a wave. This is the wave, right? Okay, now we have this wave here, right? So this wave will be having certain properties, right? That is something which we have to understand, right? So what are the certain properties that we have to understand? Okay, first of all, how we are going to write the equation to this wave, right? Okay, I'm sure this is a topic which all of you must have studied in your 11th standard, right? So where we had that mechanical wave, and we used to write the equation of the wave, right? So here again I'm going to write the equation of this wave. Let me write it like this: y is equals to a sine omega t plus kx, right? Okay, for all those who do not know how to write the equation of wave, let me just explain what I have done here, right? So basically, uh, a here, so you can clearly see it's a sine, right? See, obviously whenever we draw a sine graph is something like this, right? A wave like graph, right? So that's why first thing, sine, why there is sine? Because it's a wave like graph, it's a sine kind of graph, right? Okay, great. What is a is the amplitude. Okay, a is the amplitude of your wave, right? A is the amplitude of your wave, right? It's very irregular here, but आप लोग समझ जाइए, right? A is basically the amplitude of the wave, right? Amplitude of the wave, right? Great. Okay, now what is omega? Okay, one more thing, the thing that is inside your sine के अंदर जो आपका जो angle the thing है, right? That omega t plus kx is what you call as your phase of your wave, right? It is the phase of your wave, omega t plus kx, whatever thing that is written inside the, yes, inside the angle, inside the sine, right? Sine के अंदर angle लिखते हैं, angle के अंदर angle वाले place में आपको जो चीज़ लिखा हुआ, that is your phase in this particular case, right? You have to understand that, right? So omega t plus kx is the phase of your wave, right? I hope that is understandable to everyone, right? Okay, now what is omega here? Okay, inside phase, what is omega here? Omega is known as your angular frequency. It is known as your angular frequency. It is your angular frequency. It's written as 2 pi f, right? Where f is the frequency, right? I hope that is understandable. Okay, great. T, what is t? T is basically time, right? We'll talk about this in a bit, right? So t is the time. Okay, what is k? Okay, k is a constant that is related to wavelength. K is a constant related to the wavelength of the wave, right? Okay, wavelength of the wave, let me write it 2 pi by lambda, right? Something k is actually equal to 2 pi by lambda. आपको अभी इतना याद रखना है, right? It's a constant related to your wavelength, right? Okay, great. Okay, now next is your x. X क्या है आपका? X is basically the displacement traveled by the wave. Okay, how much displacement the wave has traveled, right? What is x? X is the displacement by the wave, right? कितना wave ने travel किया. I hope that is understandable, right? Clear. Okay, now the important thing, what is actually y? Y क्या है? What is y? Okay, let me try to understand what is y. Y is the displacement by the particle. Okay, let me try to make you guys understand this part. मान लीजिए, let's say I have a particle here, right? I have a particle here, right? Again, let's say this wave is coming to this particle, right? ऐसे कुछ आया, so obviously this particle now is going to move according to the wave, right? This particle is going to move according to the wave, right? So obviously this particle, maybe it will go down, or maybe it will go up, depending upon which wave it is being hit on, right? So what is y? Y is actually displacement of this particle, right? Y is displacement of the particle, right? I hope that is understandable, right? So basically this displacement of particle is given because now the particle is going to behave like a wave. I hope that is understandable to you, right? I hope clear ho raha hai. See, now the particle is going to behave like a wave. It will travel just like a wave. So that's why y is basically the displacement of the particle that is inside your wave. ऐसे कुछ समझिए आप, right? I hope that's understandable, right? So basically whenever you have a wave, right? Whenever you have a wave, we can simply say that I can write the equation. Okay, this is the equation for mechanical wave, right? So whenever you have a wave, you can always write y is equals to, yes, a sine omega t plus kx, right? I hope now it is understandable to everyone, right? I hope ये clear होगा, right? Okay, now if that is true, now let's very clearly go to the next part of the problem, right? The problem is, okay, let's say I have a particle here, right? And this time this particle has been hit by different waves, right? यहाँ से आपका कोई, okay, let me draw that again. मान लीजिए यहाँ से आपका कोई particle आ रहा है, right? इसने इसको यहाँ पे hit किया, right? Again, now let's say there is one more other wave that is coming from this direction, right? And it had hit that particular particle, right? Now how this particle is going to behave, right? If there was only one wave, then we can simply say, okay, this particle is going to behave according to the wave equation of that particle, right? But now here you have two different waves. Let's say, let me call this equation of the first wave to be y1 and equation of the second wave to be y2, right? Now this time you have two different waves coming to that particle, yes or no, right? Now this particle is in confusion how I should behave, right? I have been bombarded by two waves, right? So I do not know now how I should react, right? So there is certain rule to it, right? How this particle is going to behave, right? And that is something which is given by principle of superposition, right? It is given by principle of superposition. Principle of superposition. Now what this principle of superposition states? Principle of superposition states that whenever there are more than one wave that is traveling in one medium, right, the net displacement of the particle is given by the vector sum of the individual waves, right? So let me write it down. So it is actually whenever there are more than one wave traveling in a medium, then the net net displacement of the particle is given by the vector sum of the individual wave. Okay, what does this mean? This means that, okay, now you want to find out, okay, how is this, my particle is going to behave, right? Now this particle is going to behave completely like a new wave, right? So let me call that new wave by which the particle is behaving, let me call that, okay, that is some yt, right? Okay, great. So it is, so according to this definition, it will behave as the vector sum of the individual wave, right? So first individual wave is y1, उन दोनों का vector sum कर दीजिए, and this is how your wave is going to behave, right? This is what superposition principle states, right? Okay, now, okay, we talked about two waves here. Let's say there were like n number of waves. Then how would have your particle would have behaved, right? So obviously, if there are n number of waves, then it will be added n number of times, right? That is y1 plus y2 plus y3 and so on, yn, right? So according to superposition principle, this would have been the resultant, resultant displacement of the particle, right? I hope that is understandable, right? Clear hai? Right. Okay, now before I move forward, one more thing I would like to discuss, right? So whenever, okay, let's say I have this wave, I have another wave, right? So if I'm writing for this wave, y1 is equals to a1 sine omega t plus kx, and I'm writing for this wave yt is equals to, obviously the amplitude will be different, a2 sine omega t plus kx, right? So when I'm writing like that, remember, whenever the omegas of two waves, right, yaad rakhiyega, whenever the omegas of two waves are same, whenever the omegas, omega means I'm talking about the angular frequency, whenever the angular frequency of two waves are same, then we will call the source as coherent sources, right? जहाँ से भी आपका wave आ रहा है, we'll call that source as coherent sources, that right? Then we will call the sources of the waves to be coherent source and the waves to be coherent waves, right? In waves को बोलेंगे, we will call these waves as coherent waves, right? Very important, right? We are going to use this a lot, right? So whenever the omegas of different waves are same, then we'll call that we'll call those waves as coherent waves. Very important, right? समझना इस चीज को, right? I hope that is understandable, right? Okay, if that is true, let's move forward. Okay, let's say I have two sources, light sources, two coherent light sources, right? Now I hope you guys can understand what I mean, right? Let's say I have two coherent light sources. This is my source S1, this is my source S2, right? Let's say, okay, all right, great. Okay, and I have a point that is somewhere here, P point, somewhere here, right? Okay, great. Okay, from S1 the waves will go and it will meet this point P, right? All right, great. From S2 the waves will go and it will meet point P, yes or no, right? Okay, one thing that I am very much sure is that obviously from the distance, from the diagram, I can see this distance, right? The distance traveled by the wave, this is some x2 distance traveled by the wave, and let's say this is some x1 distance traveled by the wave, right? So you have to understand, this thing is very sure that the distance traveled by the wave from S2, or I should say displacement traveled by the wave S2, by the wave from S2 to the point P is greater than the displacement traveled by S1 source from S1 to P, right? Yes or no? That means very clearly I can see that my x2 is greater than x1, right? This is something which you guys have to understand here, right? Okay, all right, great. These are your light sources, right? Remember, these are your light sources. So light is actually, going like a wave, right? This is in accordance with Eigen's principle, right? Okay, light waves or light source waves, call it whatever you want to call, light source, right? Okay, great. So obviously this, let me call this as y1, right? Let me call this as y2, or the other way around, right? Okay, okay, s2 hai, so let me call it, okay, s2 ko let me call it y2, right? And for, let me call this as y1, right? So y2 and y1 are two waves here, I can clearly say that, right? So let's say y1, obviously I can write the equation for this wave, that is a1 sine omega t plus kx, right? Omegas are same because they are coherent sources, right? Again, for y2 I can write a2 sine omega t plus kx, right? So now I have done the, I have written the wave equation for the waves that are going to go from your S2 and the waves that are going to go from S1, right? Okay, now when these waves are traveling, and reaching the point P, right? Let's say these waves started from S2 and S1. Let me write it here. Let's say the waves from S1 and S2 reached point P at some t time, right? T time के बाद point P पे they have reached, right? All right. Okay, so if that is true, at reaching at point P, right? At point P, y1 will be changed to, okay, आपको अब ध्यान रखना है, y1 will be changed to, very clearly I can write a1 sine, omega is same, it has taken t time to reach that point, plus k is same and the distance it has traveled is x1, right? X1 is the distance that it has traveled. Yes or no? I hope that is understandable to everyone. Very similarly, at point P, y2 will change to, that will be equal to, yes, a2, and this will be sine, right, omega. It had omega because coherent sources, right? Again, it has taken some time t, plus k times x, all right? It has traveled a distance of x2, right? I hope that is understandable. x2, right? That much distance that it has traveled, right? How the point P going to behave? That is my first question. How the point P is going to behave, right? Now point P is going to behave according to the superposition principle, right? According to the superposition principle, right? The net displacement of this particle P is given by the vector sum of the individual waves. Yes or no? The net displacement of the particle P will be given by the vector sum of the individual wave. Yes or no, right? So I can simply write it here, y total will be equal to vector sum of y1 plus y2. Yes or no? I hope that's understandable to everyone, right? Yes or no, right? Okay, great. So I can simply write it here, yt is equals to, yes, what is my y1? Y1 is actually a1 sine omega t plus kx1, right, plus what is y2? Y2 is actually a2 sine omega t plus kx2. Yes or no? I hope that's understandable to everyone, right? Okay, this is how the resultant wave is going to behave, right? Okay, now how are we going to calculate this? That is the next question. How are we going to calculate this? See, you can clearly see there are two things here, right? Okay, sine and sine is same, okay, great, but the phase of the first wave and the phase of the second waves are is different, right? What's the difference here? The displacement x1 and the x2 displacement, although they are coherent sources, but there is a difference in the phase. Yes or no? I hope everybody agrees with me. There's a difference in the phase, and also there's a difference in amplitudes of the two waves. Yes or no? Two differences are there. So we have to solve we have to solve for the difference, right? We have to do something about this difference, right? So let's see how much difference they have, and then we'll try to find out, okay, what we have to do next, right? Okay, right. Okay, so first thing, the phase difference, we can see very clearly there's a phase difference, right? Okay, so how will you calculate the phase difference? Okay, always remember the inside the sign, जो भी आपको quantity लिखा होता है for a wave, that is your phase, right? So this is the phase for your y1 wave, this is the phase for your y2 wave, right? Okay, so let me give a simple illustration. Let's say in your maths class, very basic thing, like in your maths class, if you have been asked that, okay, find the difference between the number 42 and 22, right? How will you find it, right? You will simply say, okay, yes, I can find a difference by, yes, I will do 42 minus 20, that is higher number minus lower number, right? That is how I'm going to find out my difference, right? I hope everybody agrees with me on this point, right? Yes. So very similarly, now here also I'm asking for phase difference, right? Phase difference. All right, great. Phase difference is represented by, you can represent by anything, I'll just represent by 5, right? Okay, here I'm saying phase difference, right? Okay, all right, great. Phase difference, how will you find out? Like I said, जैसे आप नंबर में डिफरेंस करते हो, you will say higher phase minus the lower phase. I hope that is understandable, right? Okay, what is the higher phase here? See, you have to go back to the picture here. Okay, higher phase depends upon the displacement, right? So your x2 has higher displacement, right? x2 ने ज़्यादा displacement travel. x2 means the second wave has traveled more. Yes or no, right? So the phase for y2 will be higher, right? So you will simply write higher phase क्या है आपका? That is omega t plus k x2, right? Minus omega t plus k x1, right? I hope everybody agrees with me, right? This can be further written as omega t plus k x2 minus omega t minus k x1, right? Okay, omega t straight away cancels out, right? And you're left with phi is equals to k x2 minus x1, or you can simply say phi is equals to k x2 minus x1. All right, so what is this x2 minus x1 now, right? Very clearly you can see it in the diagram. X2 minus x1 is actually what? It is actually the path difference, right? Difference in the path, yes or no? Path difference, right? Difference in the path, right? I hope everybody agrees with me, right? Okay, so this phi will be equal to k times del x, where your del x is known as path difference, right? And your phi is actually your phase difference. I hope that is understandable, right? Okay, again your phi can be written as, okay, k is written as 2 pi by lambda, right? You can go back, you can pause the video, go back, right? And you can find out the value of k was, k was a constant which was related to your wavelength and was given as 2 pi by lambda. I hope that is understandable to everyone, right? सबको समझ में आ गया? I hope clear है, right? Okay, right. Now, okay, we know the phase difference now. We know the phase difference between your two, between your two waves, right? Okay, great, very great. Okay, now what? Now we have to, okay, now let's go back to the equation. We know the phase difference. Now we have to talk about how we are going to deal with our amplitudes, right? So like I said, they have been added vectorially, yes or no? They have been added vectorially. So let's deal these amplitude vectorially, yes or no? So let's say okay, let's say a1 and a2 are my two vectors. Let's assume like that, right? Let's assume like that the a1 and a2 are my two vectors, right? So we already know that, okay, we already know that a2 has a2 vector in the sense a2 amplitude was the wave which has higher phase, right? which had higher phase, right? A1 had lower phase, right? Remember that. Okay, now what you have to do here is, right, so you will just, vectorially add these two amplitudes, right? So what I will do, the amplitude with, the amplitude with lower phase will be my first vector, that is A1 vector, right? Okay, and the amplitude, those amplitude, the A2 amplitude which had higher phase, I will put it here as my second vector, right? Okay, and the difference is actually what? The phase difference. The angle between them is the phase difference, yes or no, which we have already calculated. So let me call it phi. Phi is something which we have already calculated. I hope everybody agrees with me. Yeah, yes or no? Okay, now what we have to do? Now we have to just simply vectorially add this, right? We have to use parallelogram law of vector addition, right? Resultant vector will be something like this, right? This will be your AR, resultant vector, right? And obviously there will be some angle alpha with the A1 vector, yes or no, right? I hope everybody agrees with me, right? Yes or no? So I hope everybody remembers the formula of the resultant vector, right? Resultant vector formula, if you guys remember, it is given as AR is equals to, let me write it down, that is A1 whole square plus A2 whole square plus 2A1 A2 cos of phi, where phi is the phase difference, right? I hope everybody remembers it, right? Yes or no, right? Okay, great. Okay, what about the alpha, right? I hope that is also something which everybody remembers. Tan alpha is equal to, yes, it has, if you guys remember, it's given as A2 sine phi divided by A1 plus A2 cos phi, right? That is how we are supposed to find out our angle, right? And this is the magnitude here, right? I hope everybody agrees with me, yes or no, right? Yes. Okay, now if everybody agrees with me, now we have to find out how our resultant going to behave, right? So this was the equation. Okay, let me just again write the equations, right? Let me again just write the equations. Y total, we were supposed to solve this, right? Okay, this was given as A1 sine omega t plus k x1 plus A2 sine omega t plus k x2, right? This was something which we are supposed to solve, right? Now remember our resultant vector AR is the resultant vector, AR is the resultant, resultant amplitude, how the wave is going to behave, right? Okay, now this is at some angle alpha from A1. This is at some angle alpha from A1. Remember that, right? So tell me, can I write my resultant vector as yt is equals to, okay, A1 and A2 ka resultant is AR, right? Okay, sine is anyway going to come, right? Okay, now remember, this AR is at an angle alpha higher than the A1. This AR is actually alpha angle higher than your A1 vector, right? So can I write it like that? I can write it for omega t plus kx1. kx1, it is actually, this is for your A1. ये आपका A1 यहाँ पर repeat हो गया. Plus it is actually higher by an angle alpha in phase. Yes or no? The resultant vector is actually higher in, higher in angle alpha in phase. Yes or no? I hope that's understandable to everyone, right? नहीं हुआ तो एक बार pause करके थोड़ा सोचे and you will be able to, get it, right? So your resultant vector yt will be equal to AR. AR is actually the resultant vector of both your vectors, both your amplitudes, sine of omega t plus kx1 plus alpha, right? I hope that is understandable, right? Clear. This is how now the resultant vector is going to behave, right? Yes or no? I hope that is understandable to everyone. Yes. Okay, let's move forward, right? Okay, again we are, again all of us are talking about, we are all talking about what? Light. Yes or no? We are talking about light source, right? So obviously when we talk about light source, right, so obviously we always talk about bright and dark, right? So wherever there is light, it will be bright. Wherever there is no light, it will be dark, right? So okay, whenever we talk about light source, whenever we talk about light source, whenever we talk about light source, we always talk about our intensities. Yes or no? Right? I'm sure abhi, most of you guys will be having voltage stabilizers at your home, but I'm sure all of you must have experienced sometimes what happens when the voltage is not up to the mark. Whenever there is fluctuation in voltage, we always see the tube lights or the lights that we are using, it is getting dim, it is getting dim, right? Or I should say the intensity of light is getting dim, right? And sometimes when voltage is really nice, the intensity of light is very good, right? So that is some, okay, this problem we do not face it now, but I'm sure at some point of, at some point of your life, you must have faced some these kind of difficulties, right? In which there is voltage fluctuation, the voltage that is coming at your home is being fluctuating too much, right? So because of that, you see, sometimes you see the light is getting dim, sometimes intensity of light is getting less, then it becomes higher, right? Now we have adjustable lights in which we can adjust the intensity of light, right? We can dim it. We have smart lights, right? We can dim it, we can boost it, we can make it as bright as possible. So at all those points, the main point that I'm actually trying to make you guys explain is that we always talk about intensity of light. Yes or no? Right? So we always say intensity, right? Intensity of light, right? Now, what is this intensity? Intensity means how much brightly you are actually seeing, or how much dimly you are actually seeing. That how much your light waves are coming to any particular point. Yes or no? Right? So it is being said, it is being observed experimentally also, right? That, okay, you have to understand here, for coherent sources, this is, I'm actually talking about only coherent source. For coherent sources, you have to understand here, for coherent sources, the intensity of light, I'll represent intensity of light by I, right? Intensity of light is found directly proportional to amplitude square, right? Amplitude आपका जो wave है, उस wave के amplitude के square से it is dependent, right? So intensity of light is actually directly dependent upon the square of the amplitude of the light, right? Or I can simply write, okay, intensity is actually equals to some constant A times A square. Yes or no? Or I can simply say I upon C is equals to A square, right? Very important, you have to understand, right? So intensity is something which actually depends upon what? Yes, it depends upon the amplitude of the wave that we are using, right? Okay, so if that is true, now we all know, अभी हम लोगों ने find out किया था that, okay, that your resultant vector or your resultant amplitude, right? Resultant amplitude is given as, yes, it is given as root of what? Root of a1 square plus a2 square plus 2a1 a2 cos of phi. Yes or no, right? I hope everybody agrees with that, right? Okay, great. So यहाँ पे आप देख सकते हो, this is AR whole square, I can write it like that, and this is again a1 square plus a2 square plus 2a1 a2 cos phi. Okay, let me do it again. Okay, so a1 square, can I write it IR square? That is, sorry, IR, not IR square, but IR by, actually, yeah, IR by C. I can write it like that, IR by C. Yes or no? Right? And this can be written as, okay, this can be written as, yes, I1 by C. This can be written as I2 by C. I hope everybody agrees with that. And this can be written as 2 of, yes, root of I1 upon C multiplied by root of I2 upon C cos phi. Yes or no? Right? So this is IR upon C is equals to I1 upon C plus I2 upon C. I hope everybody follows, plus 2 into I1 upon C. Sorry, I1 I2, let me call it root I1 I2 upon C. This is cos phi, right? So this C is actually cancelled out here, right, in all the terms, right? So you will get simply IR is equals to I1 plus I2 plus 2 of root of I1 I2 cos of phi, right? I hope so. Intensity, resultant intensity also can be written as like that, right? I hope everybody agrees with that. Yes or no? Resultant intensities can be written as IR is equals to I1 I2 plus 2 root of I1 I2 cos phi, right? Okay, so this basically this equation, what this equation is actually stating, right? This equation is actually stating that, okay, that depending upon the phi, that is the phase difference, depending upon the phase difference, we can actually say, we can actually change the intensity. That is what it is saying. Yes or no? That intensity is depending upon depending upon the intensities of different waves, right? And depending upon the phi, actually I can change it, right? I hope everybody can agree that this equation suggests that the distribution of intensities is non-uniform. Yes or no? It is actually non-uniform. इसका मतलब क्या है? इसका मतलब wherever there is intensities, मतलब we can have places where intensities can be more, and we can have places where intensity can be less, right? I hope everybody agrees with me, right? Yes or no? So by this equation I can simply say I can always find a point where I can have a bright spot. Bright spot means where the intensities are higher or intensity is maximum. Yes or no? So we call that constructive interference. Whenever two waves are coming, whenever two waves are coming, you will actually can see the intensities there, right? When two waves are coming, there will be places where you will see bright spot, there will be places where you can see dark spot, right? So wherever the places, okay, let me write it, constructive interference, right? So इसका मतलब क्या है? When the intensity of the light is maximum, right? Intensity of light is maximum, or where the places where we observe bright spot, right? These are the places where we observe bright spot, right? I hope everybody agrees with that, right? So this will only happen when your IR, that the resultant intensity, or slash your AR, that is the amplitude, is maximum. Yes or no? When it is maximum, then only it can happen, right? Okay, we all know that IR is written as, yes, we know that it's written as I1 plus I2 plus 2 root I1 root I2 cos of phi, or you can also write AR. You know, AR square is written as A1 square plus A2 square plus 2 A1 A2 cos of phi, right? So in sub mein, if you want your IR and AR maximum, then basically all you have to do is you have to maximize your cos phi. Right? So you have to make cos phi maximum. And we all know cos phi is maximum, value is plus 1. Yes or no? And plus 1 can only happen when value of phi is 0, is 2 pi, is 4 pi, 6 pi, and so on. Yes or no? So we can simply say phi will always take the values such as, okay, you can say 2 and pi, right? The phi should always take values 2 and pi, where n should start from, yes, the n should start from 0, 1, 2. So n should be actually whole number, right? I hope everybody agrees with it, right? So if that is true, let's also talk about, okay, let's also also talk about the path difference. What should be the path difference, right? Path difference के बारे में बात कर लेते हैं. Path difference. Okay, let's talk about the path difference also. We already know हम लोगों ने we have calculated the phase difference is given as, if you guys remember, it was given as k times del x, right? Well, del x was the path difference, right? Or you can also write it phi is equals to 2 pi by lambda multiplied by del x, right? Yes or no? Now here del x is the path difference, so I can say del x is equals to lambda by 2 pi times of phi. Yes or no? I hope everybody agrees with me, right? So your del x is equals to pi by lambda by 2 pi multiplied by, for constructive interference the value of phi should be, yes, 2 pi 2n pi, right? This is 2n pi, right? So just cancel your pi, this will also get cancelled, so you will get your path difference should be equal to n times pi. Path difference should be equals to n times pi. Yes or no, right? So at these path difference, that means the value of n is actually again 0 1 2, right? So all this, so that means del x का value क्या क्या आएगा? It will come out to be 0, it will come out to be, yes, lambda, it will come out to be 2 lambda, come to 3 lambda, and so on. So all these values of path, that means when it's very simple, when your the wavelength is lambda, 2 lambda, 3 lambda, at those places you will actually see what? You will actually see bright spot, right? I hope everybody agrees with me, right? Second, we have to talk about destructive interference. Destructive interference means the places where we see dark spot. The places where we see dark spot, right? The places where we see dark spot, right? Okay, so this will only happen when your IR or your AR is minimum, right? This will only happen when your IR and AR is minimum. Yes or no, right? I hope everybody agrees with me, right? So if that is true, I can write my IR as, yes, I can write my IR, we already know, I can write it like I1 plus I2 plus 2 root of I1 root of I2, right, cos of phi, right? Just like we did it in the previous case, right? Or we can always talk about amplitude. AR square is equals to A1 square plus A2 square plus 2 A1 A2 cos of phi. Yes or no, right? So this will only happen when you will get destructive interference when the value of cos phi is minimum. Yes or no? You can write cos phi is minimum, that is equals to -1. -1 is the minimum value of cos phi, and right, and we all know the phi, the cos phi, sorry, the value of the values of phi for which your cos phi is -1, right? The values are pi, yes, it is 3 pi, it is 5 pi, it is 7 pi, and so on, right? A plus sign and so on, right? Yes or no? That means it should be, yes, 2n plus 1, 2n plus 1 times your pi. Jara check karo, right? Okay, so your n should be, now this time your n should be equal to, start from 0, right? 0 1 2 3, your n should be whole number. Okay, let's try to find. Okay, when I put n 0, very clearly see it will come out to be pi. Yes or no? When I put n is equals to 1, you put n is equals to 1, it will come out to be 3 pi. You put n is equals to 2, it will come out to be 5 pi, right? So basically n should start with whole number, so your phi will be 2n plus 1 times pi. Yes or no? I hope everybody agrees with me. Yes. Okay, now again let's talk about the path difference here also, right? Okay, now path difference. Okay, again path difference, we will recall the phase difference. Phase difference phi is given as k k times of part difference del x, right? And we all know phi can be written as 2 pi by lambda upon del x. I hope everybody is following this, right? Okay, so I can simply write del x is equals to, yes, lambda by 2 pi multiplied by phi, right? Okay, so we all know in order for you to get the destructive interference, you have to put the value of phi to be, yes, 2n plus 1 times lambda. Yes or no, right? Okay, great. So that means your pi is cancelled out with the pi, right? You will get del x is equals to lambda by 2n plus 1. Yes or no, right? You can actually further solve this thing as इसको आप अंदर ले जाओ. This will be lambda n plus lambda by 2. Yes or no? Or you can simply say del x is equals to lambda को कॉमन ले लीजिए. This will be n plus half. Yes or no? Okay, so this will be the path difference, right? I hope everybody agrees with me. So for all these path differences, right, we will get a dark spot, right? So this is what your interference pattern is. So basically what we have did in this lecture, actually, let's go from the start. So we were talking about interference of waves, right? How the waves are going to add up whenever there are two waves that are coming, how the waves are going to add up, right? We talked about the mechanical wave, how you can represent a mechanical wave, that is y is equals to a sine omega t plus kx, right? So we discussed different the terms which are used in your mechanical wave, right? Then we talked about a situation in which there are two waves that has been bombarded to a point, right? Now that particle, how that particle is going to behave, it will obviously behave as a new wave, right? But how we are going to predict the displacement of that new wave, right? That we do by principle of superposition, right? So according to that principle, whenever two or more waves are traveling in the medium, then the net displacement of the particle is given by the vector sum of the individual waves, right? So okay, so we did try to do a problem in which we had two light sources, and those two light sources, right, it's going to a point P, right? And there we try to calculate, okay, how is the net displacement of that particle P, right? We try to calculate it, right? We talked about the phase difference, right? And then we try to find out the resultant amplitude of the resultant wave, yeah. And then we try to find out the displacement. Came out to be yd is equals to ar sine omega t plus kx1 plus alpha, where alpha was the resultant phase, right? Okay, great. Then we talked about the intensities, right? Intensities for coherent sources, it was depending upon the amplitude square, right? And then we talked about the see, from the formula we got to know, okay, the intensity does not remain same. There is a variation. Sometimes you will see higher, sometimes you will see bright spots, sometimes you will see dark spots, right? So that is something which we would try to find out. We talked about constructive interference, where we see bright spot, and we find out for which values we will see bright spot, for which path values we will see path difference value, and for constructive it was coming out to be n pi. We also talked about destructive interference and the places where we see dark spot, right? And we find out the path difference where will see destructive interference, or I should say dark spot, right? So the path difference was coming out to be lambda n plus half, right? So I hope you understood the lecture. That's all for today, right? So I hope you understood it. If you have any problem, any doubt, you can ask in the comment section. That's all for today. Thank you and have a nice day.